G'day, you nines. Just had a question after class about this question 3 from the revision sheet that we did today. So the question is, determine the equation of each line in gradient intercept form. So let's just quickly remind ourselves, gradient intercept form is written like this, where there's a y equals mx plus c. And the m is the gradient, and c is the y-intercept. So that's what we're looking at. That's what we're asked to find. So let's have a look at this first one. It asks us to find the point where, find the line with a gradient of m passing through the point P, where m, the gradient, is 3, and there's a point on the line that is 1 minus 2. So we can get started. We can straight away say that we know what the gradient is already. So we know that y equals, well, we said the intercept form is y equals mx plus c. We know what m is, it's 3. Y equals 3x plus c. We don't know what that value is, but we do know that the point 1, where x equals 1 and y equals negative 2. So remembering always the first coordinate is the x value, the second coordinate is the y value, is in the line. So let's substitute those numbers in and we'll see what we get. So the y is negative 2 equals 3x, so 3 times 1 plus c. So negative 2 equals 3 plus c. We know from our algebra, if we want to find out what c equals, we need to get rid of the plus 3. So we're going to subtract 3, and if we do it to one side, we've got to do it to both sides. So we're going to subtract 3 from both sides. We're going to get that minus 5 equals c. So now we know that what c equals and what m equals, we can write our rule. We've got the y equals, the gradient is 3x minus 5. And if we wanted to check that, we could pop in our points that we know sit on the line and say, okay, does negative 2 equal 3 times 1, which is 3 minus 5. 3 minus 5 is negative 2. Negative 2 equals negative 2. So our check suggests that we are spot on there. For the next one, we're asked to find the rule in the same form, y equals mx plus c, using these 2 points here. Now, the first thing I would do here is calculate the actual gradient itself. So we know that the gradient equals y2 minus y1. The difference in the y value is divided by x2 minus x1. Remember what gradient is? It's the rise divided by the run. So the change in the y values is the rise in the graph. The change in the x values is the run. So let's put our numbers in. Let's say that the point minus 2, 4 is the first point, x1, y1, and the point 1, 10 is the second point, x2, y2. So the top part is going to be 10 minus 4, the difference in our 2 y values. And now we take the difference in our 2 x values, 1 minus negative 2. Okay, the second of our values up here. Now we've just got to finish the calculations here. 10 minus 4 is 6. 1 minus negative 2. So that's a negative. So subtracting in the negative direction is a positive. So 1 plus 2 is 3. So the gradient is 6 divided by 3, which equals 2. So now we've got the start of that. We can start to put together the rest of the rule. We can say we now know it's y equals 2x plus c. We've still got to find out what this c equals. So let's substitute a point in. You could choose either of those 2 points. I'm going to choose the point 110 just because there's no negative numbers there. So substituting this in, the y value up here is 10. 10 equals, the x value is 1, 2 times 1 plus c. So 10 equals 2 plus c. Now, our balance beam approach to solving things, we want to get c by itself, so we can take 2 away from that side. We have to take 2 away from the other side as well. So subtract 2 from both sides, and we've got that 8 equals c. And that then gives us our answer. That y equals, we calculated the gradient as 2x plus 8. Let's just double check this. Let's just substitute the numbers in and see how we go there. So our points, let's use the point 1, 10. So 10. So just to check. So say, okay, let's draw this line, put a check here. 10 equals 2 times 1 is 2 plus 8. And that side equals that side because 2 plus 8 is 10. So we've checked and we can see that our answer, y equals 2x minus 8, looks pretty good.